Well, welcome back to another lazy Sunday. I don't know which one of these I'm going to choose. So we've got two. They're a little bit of a mystery without opening them at least. One of them well, I know it has a 555 timer in here, so I'm going to guess it's probably like a square wave generator, maybe adjustable frequency, or duty cycle, I don't know. And the other one, I cannot tell, but it sort of looks like one of those. In fact, do you want to come in a bit closer? It sort of looks like just a tester board, but we've got two ICs on here. That looks like a crystal to me. VCC across there, I don't really understand, to be honest. It's got a battery box, so we could go for this one, or we could go for the 555. Now, I haven't played with the scope in a while, so let's give the 555 a go. So what do we have here? Oh, if you can get into it. Okay, right. We've got a circuit board, various components here. I'm not sure what that is. Did I get this in February 2018? Possibly. Wow, it's been a long time. So I've still got loads and loads of these little kits lying around. So we've got a nice circuit board. Thankfully they've printed all the components on there, so I don't need to worry about where they get placed. But we also have a diagram, which is brilliant. Oh, it is that way around. And so we've got all our components listed. So the IC is an NE555. Okay, so you can see the board layout here. We've got ground and VCC over there. Now, where did I see it on the board? Oh no, it was the other board that I was looking at. So single-sided. What do we have on the reverse? Okay, kind of unreadable. However, let's see what we can see. So we've got a diode coming in on the supply voltage. We've got our 555, two fixed resistors. So that means the frequency is fixed. Is that right? I think that's right. And then do we have an adjustable pot anywhere? There's definitely an adjustable pot here, but I can't quite see it on the diagram. So let's put this together and we'll figure it out later, exactly what it does. We'll put it on a scope and we'll find out. Oh, I need a multimeter to measure the frickin' resistors because I can't read the codes. So I'll start by just throwing some stuff in the board. These are 10K resistors, so let's do those first. I haven't been making very many videos recently. I've had a lot on in my personal life. So, and in fact, I haven't really been doing any kind of hobby stuff because of my personal life. So it's nice to get back to doing something I find incredibly relaxing, which is putting together little kits from China or designing my own, but putting together someone else's creation is just as fun as making my own. In fact, I've got a kit from Dave Darko, which is his Star Wars inspired big badge type thing, kind of a curio, I guess. So I'm looking forward to putting that together, but I want to do it properly, so I'm just gonna leave it until I've got enough time to really concentrate on doing it. And then we've got, what else have we got here? We've got two there. Is that a third? No, that one's different. So these are the same, which means they are the 1K. I'm just going to double check that with a multimeter. No, they read 10K, which means I've probably put the wrong ones in. Yeah, okay, so I put the 1K in the 10K slot because I misread the resistor. Clever, clever me. So let's pop the 1Ks in to the correct slots. One there, one there. I wonder what this thing's going to do. I mean, judging from the schematic, and I'm no expert in reading schematics, but judging from the schematic, it looks like it does changes in the duty cycle. But then I don't know why their variable resistor is on the output like that. Seems a bit strange to me, but it could well be right. So these are 10K. So I've been working on my little segment display, which has been a lot of fun, but I haven't had a lot of time for it recently. Not been able to put my head in the right place to do it. So that's pretty cool. I've also been working on those badges. Do you remember the crap badge? Well, I've put some kits together, so I'm going to put some up on Tindy. They won't be very expensive. Well, at least I hope not. I haven't actually costed it up yet, so I'll do that. I've just sort of spent, I need to sort of look how much money I spent on them and then figure out where the, oh, well, that one's not in the same orientation. Someone's not going to like that. And then figure out where the sort of profit loss line is and then do it from there. Right, what else? Trying to put all the small components in. So that's basically all of the resistors, and then we'll go from there, I think. So we've got two 100K. That's what they look like to me. And they are 100K. Yeah, so I'll put those up on Tindy, and I guess I'll do a little video, but I might not, and I might just, you'll just have to be surprised when they turn up. I also have, come on, there we go. I also have two binary clocks left, it turns out. I had a look in my sort of box, and there were two kits in there. I think I was saving them for just in case someone got a kit and it didn't work, so I could send them a new one. But luckily no one complained about anything, which is, you know, fairly fantastic. I was really pleased that no one found any fault with anything that I put together. So what have we got here? That is a 15K. So yeah, I might either pop those up on Tindy or do a little competition for when I release the binary clocks. No, the badges. All right, 15K. Where are you? There you are. Is 15K a strange value? It sounds strange in my head. I'm not really used to saying 15K. What have we got here? That is a 1 mega ohm resistor. So yeah, that will be going up at some point, but I've also got a load of crap critters. That's the little cricket. Got a load of those boards created, and I'm just waiting on some parts. And then if anyone fancies a crap cricket, they'll also be going up on Tindy. And I need to get the new ones, which are the fireflies, done. They need to be sent off to be fabricated, but I was looking for a way, and I'm still going to actually, I was looking for a way of 4.7 of having it light through from the other side. Now Boldport, I don't know if you know who they are, but it's a good idea to give them a Google who they are. They do some amazing PCB designs, and they had one which was like a 7-segment display where the LED shone through the PCB material. So the solder mask had been removed from a section of it, and the LED would light from underneath, and then it would glow. So the different segments were on there. It's pretty darn incredible. I was kind of inspired by that, and I wanted to do that on my own Firefly. They were just going to be surface mount LEDs across. Have I got one lying around here? One of the crickets? No, I don't think I do, but surface mount LEDs were going to be on it, so it was going to be an interesting one. Right, I think that's all of the resistors, so let's get those soldered up. Oops, I forgot to press record and we've already started doing stuff, sorry. So I'm just soldering these in. I was saying that I've got a new tip on my iron. It's a lot thicker, this tip, than the one I had previously. I put that on because Sion had sent me one of those, or rather I'd bought from him, one of those, what were they called? They were the addressable, the addressable 7-segment displays. I cannot remember. Anyway, I put a small tip on to do those, and I've gone back to having a nice big wedge tip, which should make short work of these connections. It'd be nice if my cable wasn't trapped on stuff. No, that's not all of them. There's one left down here. There we are. Let's get those cut off. Oh, I've missed one. I can see it there. Got lost in a forest of legs, unfortunately. I'll just pick these up with a magnet, which I like doing now. Super easy to do that. Solder those last few legs on that I'd forgotten. There we are. All right, what's next? So we've got some little capacitors. Let's do some of those. So we've got 473. So it's just there. And another 473. Oh, there are lots. We'll pop all of these in. Oh, so the reverse LED thing. So I haven't tested it yet, but I'd like to. So I'm going to design a different board first. I thought I'd go with a little like the bold port thing, but instead of a 7-segment display, I'm going to make a dice, I think. So it's going to have a microcontroller on it, and it will have 6 LEDs on the reverse, and it will display a number based off shaking it. So I'm going to use a one of those little vibration sort of sensors. They're not sensors really, they're vibration switches, I guess. I've got one more 104. In fact, I'm going to switch this one out. So yeah, I thought that would be a bit of a fun experiment. That's a 104. Hang on a minute. Oh, there's the 103. None of these are really sized for their holes, it seems. So that's a 103. And we've got one 104 left, which I can't. Yes, I can. It's just there. So yeah, I thought it would be a fun experiment and an interesting PCB design to do, because I'm going to try and make it 3D, so it'll have a bottom section and a top section. And like BoldPort did, I'm going to make sure that the components are the things that hold it together. Well, not make sure, I don't know how I'm going to do it exactly, we'll see. I thought it'd be fun to try it. I've got a diode over here. Where does that go? Oh, I see. Just here. All right, they're all going to hold in pretty well, so we could probably put a few other bits in. So these big capacitors maybe. Pop one in there. Oh, actually it's caught on the reverse. So let's just go in and fold that out of the way. And one more over here. So do let me know if you've done any kind of PCBs like that. I mean, I made that audio cube many years ago for a Hackaday prize, I think. And that was a lot of fun, and that was using 3 PCBs separated by standoffs. That was a lot of fun. I've lost something. There we go. But I'd love to hear your experiences of, let's call it creative PCB design, I guess. Also, if anyone's got any ideas how it should choose the number, I was just going to implement some kind of random number generator, but there might be some hardware methods for doing that that are interesting. Or maybe I could just use the ADC on whatever microcontroller I'm using and have it float so that the numbers are fairly random. But there must be some interesting ways. There we go, that looks like all of them done. Right, that looks like a bit of a hack job. I can see a couple of connections if I turn the board that I need to just go over. I'm not very close to the board right now, so it's very difficult to see these, but that one's not very well soldered. So we've got a couple of transistors. They can go in, can't they? So these are S9013 and S9013. I don't know what the 9013 is. Let's find out. Well, it turns out it is just a standard NPN transistor. So something like a 2N222 is like a replacement for these, isn't it? Yeah, it's pretty standard. And let's do everything, shall we? Right, and the rest can wait. Oh, do you know what? Having not been looking at this, I can see that we've got a sine wave, sawtooth, well actually what that's triangle, sawtooth and square wave just there. So what it's doing, it's going to be using the resistors and the capacitors to change the waveform, I guess. I'm not quite sure what the pot would be. Is that oh, it's got to be amplitude, hasn't it, on the output? Hasn't it? I think that's right. Oh, flip. Oh, well. At least I finally got there, right? Let's flip this over and solder those in. So there we go. Now, we've got our IC. Now we need to chop some of these off. So I need 2, 2, 2, and then the output and the input, I guess. So we just need lots of 2s. Oh, for heaven's sake. Right, we're going to do the burning our fingers approach. Ow, okay, I did burn my fingers there. That was clever, wasn't it? But at least one held in for a second. Five years later. There we go. Right, let's get it powered up and have a look at it on the scope. Right, let's get this hooked up, shall we? So scope on. I've got ground connection here, and this is our signal. Little bit of a janky setup here. Look, we've got everything connected via these sort of crocodile clips, but whatever, it will work, I'm sure. I've got power going into the device over here from my power supply. Let's turn that on. So that is 5.25 volts. That will be fine. You'll notice there's a bit of noise here on the scope, and that's because my lights that I've got in the room sort of couple. or this is picking it up because it's a big antenna, I guess, but this big cable here, but whatever, we'll work with it. I mean, ordinarily when I'm using the scope, I don't have these big sort of video lights on, but let's just continue and we'll see what it looks like. If I need to, I'll turn the lights off. So I'll turn on the output. Okay, we've got a triangle wave already. That's where this jumper is set, and we figured this must be an amplitude pot that's on here. So let me just turn it up. So that potentiometer there, we figured must be some kind of thing for the amplitude, and it is. Ooh, it doesn't like that. So you can see that we're not triggering properly. I bet that's the lights. Yeah. Yeah, we're jumping around a little bit, but we'll leave them on. So we've got amplitude adjustment here. So where's it go down to? Well, very small millivolts with all our noise from the lights in there too, but let's turn it back up again. Oh, that's just, we'll cheat and go auto. Oh God, that's, there we go. That's a bit better. You don't mind being in the dark, right? We're gonna do that for a while. The other light over here is probably also, yeah, look. Let's do the rest of it in the dark. You can see that's a nice straight line. So yeah, we've got amplitude adjustment here. I wonder if we give it enough amplitude adjustment, it won't trigger. Hang on. Yeah, there we go. So if we give it enough amplitude, it's cancelling out everything else and this is triggering properly. But if we go back down, you can see all the noise starts to come in. Not quite sure why that's the case, but it is. So a nice clean signal there for the sawtooth. A couple of little artifacts here, little jumps, but it's quite nice. Let's jump to a different one. Let's go with the sawtooth. Wow, that's nice. It looks like little shark fins, doesn't it? That's the kind of wave I would draw when I was a child. So that's working all right. Let's go to the square wave. Bit of roll off there, but then my scope's not, I've not sorted my probes out properly. So, oh, wrong one. That's not terrible, is it? Okay, and the last one is good old sine wave. So we're getting, what, 3.1 kilohertz as the frequency. Let's change this and see if it does change anything. It does change the frequency too, so I can see it's gone down to 2 kilohertz. And up here, whoops. Up here we're at 3 kilohertz. So it does change frequency, but it is changing the amplitude. Cool. Well, this is just I guess it's a function generator, isn't it? So I kind of like it. It's very cheap. I'll try and find a link to it. Heaven knows where it's from. But it's a fun little kit really to put together, isn't it? So I'll see you next Sunday, maybe. Or a Sunday in a month's time. You know me.